I need to say that it's a pleasure, and I feel honored to be kicking off this day for a second year in a row. And first of all, I would like to congratulate all of the organizations, but not only them, but also you and us for having such a great event here in Bilbao. Almost 4,000 people registered. It's something unique, not only in Bilbao, Euskadi, Spain, but also Europe and globally. So I think that we are all lucky to be here. Sometimes we state some, let's say, sentences that are a little bit controversial.
Sure.
So I usually state that probability is irrelevant when we talk about critical infrastructure protection. It's irrelevant because it basically is one. We will talk about that.
Give me and the audience like the simple version of risk. What's the formula?
Yeah,
it includes probability.
The traditional formula of risk is basically, threat times vulnerability times likelihood probability times impact. What I'm trying to state is that please take the likelihood probability out of the equation, because especially when we talk about critical infrastructures, it's one. So you don't need that, right? Way to address the protection of these infrastructures, you can use compliance as a driver, but not as the end of the start. And
Exactly.
also bringing some of your nice statement, you always say that if you are a critical infrastructure service provider, you will be targeted. And definitely, if you are targeted, you will be compromised.
Whether you're doing a compliance regime because you're in a sector that the government is telling you have to follow certain standards, certain frameworks, etc. If you're a business, especially an asset-owning business, the large industrial companies we're talking about serving and protecting today, you're thinking about, you only have a certain amount of money for any particular function, including cybersecurity. And even if your budget has gone up recently, it still is a finite resource, how you're going to spend it. Many companies try to use these complex formulas to figure out where to spend different parts of money on the large enterprise. So if this is, and including they will factor in likelihood, using algorithms and hoping that they're getting the risk about right. One way I do it is using a visual to describe this. If this is your whole enterprise, this includes all endpoints, all networks, all computers, all the different processes that are going on in a large industrial enterprise. You need to protect these things to the best of your ability with what we'll call cyber hygiene. Some people have a problem using this term. That's fine. Cybersecurity people argue over definitions all the time. But let's just say you're doing your very best to apply the right tools and technologies, the right people, training your people, etc., the right governance structures to protect everything. You need to do that to the best of your ability all the time. However, if you are critical infrastructure, now I'm going to repeat Samuel's statement. It is a proven fact. We can talk about it more if this is upsetting to you. It is a proven fact that you will be a target of certain adversaries. And also, even if you're doing the very best job on hygiene, which you need to do across the whole enterprise, it is a fact that certain adversaries will target things inside your enterprise that are most important to you. They won't go after everything, but they will target things that could potentially kill your company. Or if you're a military unit, kill your ability to perform your mission. So the way I say it is, and this is the introduction to the methodology that this presentation intends to discuss a little bit at least, which is called consequence-driven, cyber-informed engineering. I say it slowly. It's hard for even English speakers to deal with this acronym, so we just reduce it down to CCE. But the pieces matter, and particularly the first word called consequence. That's where Sam was getting at the point of, for things that really matter, and I think it's even the title of this talk, for things that matter most, or things that must not fail, you can't just keep applying more firewalls and more security incident and event management systems and more intrusion detection and more policy. There's some things inside large asset-owning enterprises that simply cannot be allowed to fail, and for which hoping that no one attacks them or no one gets them is not really a good strategy. Some of you in businesses who ever touched sales before, you'll hear your VP of sales say, hope is not a strategy. You have to be able to prove what you're doing and demonstrate the effectiveness of what you're doing. In this case, that means there are some coming out of Idaho National Lab and a couple other places. We were going to also mention Sarah Flukes from Deutschland. There are a couple places where people are saying we can't just trust these digital technologies for cybersecurity. They themselves are made out of software. These technologies themselves are extremely complex and hard to understand. And since they're interconnected to everything, even if you have good segmentation and other defendable architectures, since they're interconnected, they too are something that a talented and well-resourced adversary can reach and start to turn to their advantage against you. We're starting to see that some first principles engineering approaches can help mitigate the worst possible consequences for things inside of large industrial enterprises that you simply can't tolerate a digital bad actor reaching and creating a catastrophic effect. CCE stands for consequence-driven, cyber-informed engineering, the three parts. Was an attack on the United States using an approach that nobody really thought of before. Or if they did, they didn't take it seriously. Using large commercial jets to fly into skyscrapers in a city. It looked like a hijacking, but it wasn't just a hijacking in the traditional sense. So after that happened, now we're talking about going into 2002, 2003, the US government commissioned teams to try to figure out other ways that substantial damage could be done, substantial harm could be caused to the United States, especially by targeting infrastructure. And depending on how old you are, you can imagine the state of business technology, IT at the time, 2003, 2004, et cetera. And so Mike was part of teams. They had red team and blue team, red team attackers and blue team defenders targeting critical infrastructure, and they found, the red team anyway, found it's really not that hard. We can potentially cause really catastrophic effects by doing this. A few years later, when Mike was at the Idaho National Lab, INL, again, for short, he was a very important part, he wasn't the only person, but in a demonstration called Aurora. And Aurora was the first time where, using digital means, causing over distance, they were able to make a large diesel generator self-destruct by repeatedly sending it in and out of phase. Up until that point, people like Sam, myself, and others were saying, you know, this is possible. It's possible that the cyber attacks that are happening in IT could cross over into OT and cause some really serious problems for companies and countries. But you can imagine executives going, yeah, but we have limited amounts of money. I haven't seen it yet, so it sounds a little bit academic and theoretical. When Idaho National Lab and Mike Asante did the Aurora demonstration, and when it got videoed, and then when it got put on YouTube, it was pretty easy to show senior people, and engineers and cyber people too, by touching a keyboard in a certain pattern, you can cause a large machine to destroy itself. Or let's say you're a large industrial company and you have dozens of them in Basque region and around the world, right? Think about all those assets. If you look at the, I think you said the normal processes or the best practices for ICS security, the SANS Training Institute and a couple other organizations typically once a year will refresh their list of these are the best practices, things that everybody should be doing to have good cyber hygiene. Number one, it's a list of 20. Number one is always asset inventory. Know what you have. How can you secure what you don't even know you have? And this is the hardware. And if you go to the second one, it's all the software that's on that hardware. Software, operating systems, patch levels, version numbers, device drivers, an infinite level of detail. If you don't know these things, however, and by the way, no offense to anybody that is in one of these companies, you probably know already, these companies don't know what they have. Typically, there's big question marks over what they've purchased and deployed over the years. Sometimes, in order to try to find out what they have, they'll call their suppliers or their integrators and say, do you know what we bought? That's one way to figure out what you have. The reason why you want to know what you have is because the people that are looking at you from the outside, doing open source intelligence by everything that's online, using Google and Shodan and other tools, just reading the press too, and going to conferences. They know a lot about you before they even have begun to touch you. If you're going to have any chance to defend against them, you at least have to know your infrastructure as well as they do. Ideally, you know it much better. The first thing is identifying what matters most. We call this consequence prioritization. So again, using my hand gesture, out of the whole universe of processes and systems and people, including subcontractors and suppliers, that you use to operate your business, what are the things that, if those processes or functions were taken out for more than a day or two, you'd be dead? Because that's what the adversary is targeting, not necessarily everything, the things that matter most to you. So probably if you asked yourselves and asked your CEO, looked at the senior staff, how would you kill our company? What would you target? That begins to lead you to the right places in the company where you can have this conversation. Most of the time people don't think about it. They're thinking about how can we grow our company or how can we sustain our company, not how would we kill us. But somebody is thinking about how to kill your company. You need to do the same thing. The second step is called, and these are the two I'm going to skip through quickly. Second step is called system of systems analysis, and that just means looking, once you've identified the handful of processes that must not fail, not this, but this, all the supporting infrastructure, hardware, software, people stuff that supports those critical functions. The third thing is called consequence targeting, and that's when you put on your bad guy hat or your red team attacker hat and say, okay, so now I know the playing field, I know the landscape that I can operate through to reach those functions that I'm trying to target, that I'm killing. What are the kill chains? What's the recipe or the choreography using cyber means to be able to reach and then create the effect, the bad consequence that I'm trying to create? The last step is called mitigations and protections, and that means once you know those things, what are the typically engineering types of things you can do to, as we say, take the targets off the table, so that if an adversary were to get all the way down through your systems and develop a payload and have the right people on their teams, the engineers, the safety systems experts, the process experts, the cyber person, the IT and OT people, if they were able to assemble all that, then when they finally push the button for the attack to kill your critical processes, it just wouldn't happen. Because behind the scenes, you've implemented some out-of-band or other type of protection that will keep that machine from killing itself. It might turn itself off, it might go into a safe state, which will cause problems for production, but it will not destroy a large piece of industrial equipment or hundreds of large pieces of important industrial equipment that if you were to lose them all at one time and have to replace them, it would take months.
What is the role do you think the engineers need to play in this new approach, and especially in protecting the critical infrastructure?
I'm glad you bring it back to engineers. I think that is our main focus, because we're so used to thinking, oh, we'll just throw some more cybersecurity at the problem and it should be okay. In this case, I'm using the simplest definition for me of an engineer is someone who solves problems. And this fact that we are not really fully protecting to our own high degree of confidence things that matter most is, in the end, an engineering problem. It's not more technology in that sense. It's using approaches that have worked for us in the past when we built bridges, when we figure out ways to keep airplanes in the sky, all types of complex processes using physics-based approaches. So the engineers, once you've done the first phase of where are the most likely systems, what are the things we depend on most, can begin to imagine how they would make it so that even if that system was told to self-destruct, and you can think about the Triconics attack in Saudi Arabia that made it through the safety system almost as well. What can we do to make sure that this machine or these machines ultimately are protected? Sometimes using analog approaches, sometimes using backups. We would say a non-identical backup, a replica machine that we keep offline, and it is also different than the one that they figured out how to destroy. You bring that online, so it gives you time to stay alive. So some combination, I think, of the first phase, identifying what really you have to protect, and then using as much as you can, and we can talk more about this some other time or later, what are those engineering approaches that the lab and others have used to protect large industrial equipment in the water sector, in the electric sector, in the oil and natural gas sector, and some military applications too.
Can we use, or how the industrial and average company could potentially use this new approach of CCE in the way that we protect not the critical infrastructures only, but an average industrial company?
It's fine. Thanks, Fred. That's right. Ransomware is now affecting everyone, and the only thing we can say for sure is that next year it will affect more people. It is a growing business, and so far we have not figured out a way to even begin to slow it down. When CCE was first developed with Mike Asante and team, they were thinking about nation-state level attacks, very well resourced adversaries going after things that really matter to a country and to big companies. And asking you, could you live without this automation technology? Ukraine provides some examples we don't have time for. But it's funny how ransomware is coming around, mainly touching IT so far, asterisk with some exceptions, that it is starting to go in and cross the barrier into OT in some cases. And it's forcing companies, not necessarily just industrial, right, but universities, towns, and a number, with Norsk Hydro, we get into a large manufacturer. They're trying to see, oh my God, we needed our IT systems and our orders, right, to know what to build. So that was a critical dependency that they hadn't really thought of. And they had to scramble to figure out how to make it happen. And they documented very well how they did scramble. But you can imagine for your own company in terms of response and preparation for ransomware, imagine how you could still do your job, your core job, if you lost certain critical data on the IT side for a long time, and then what if it was able to spill into operational systems, and you started to lose confidence and trust in those systems? What would you do? The only thing you can do is practice and take it seriously.
To give you the opportunity to close this session, giving us, all of us, some advice on how to build trust between us in the Basque country, in Spain, and more broadly in Europe and globally.
Sure. Yeah, great final topic. Again, talking about building trust for environments where trust can be lost in all the automated processes that we've built in, right? So maybe this conference and the Basque country is as a microcosm. When we talk about an individual, say, Basque industrial company, the idea that people in stovepipe functions, the engineers, the operators, the senior leaders, people in procurement, all these, I could do 10 probably different categories, who normally don't talk to each other, they need to start to get together more regularly, have some vermouth together, and become a first-name basis, because this issue involves their expertise being combined. When we start to go out into the world outside of Basque country, first of all, the Basque government agencies, cyber agencies, all need to be in better communication. Throughout Spain, that's the case. And then clearly, as we go into Europe and other allied countries, participating in different forums where you can learn what's working for different places. I think it's Alan Powler, the founder of SANS Institute. He has a nice way of cutting through all the theory and all the marketing by saying he wants to know what works. So I like your different ideas, and I like to hear what comes out of the different product and security companies, but at the end of the day, working with other countries across different sectors, what works for them and what are they willing to share? And the willing to share part is the trust part. You have to have the relationship before that information can flow freely.